know that feeling when you look at a long, messy algebra problem and your brain just short circuits? Well, today we're going to change that. We're going to become the Algebra Cleanup Crew. And I promise you, by the end of this, you'll be able to take that messy math and make it look clean, simple, and maybe even beautiful.
Okay, take a look at this thing on the screen. It's a jumble, right? A total mess of letters and numbers and pluses and minuses. Honestly, it looks like my shopping cart after a trip to the store with no list. Everything's just tossed in there, and it's almost impossible to see what you actually have. But here's the cool part. What if I told you that cleaning up this algebraic mess is actually no different than sorting your groceries? Seriously, it's like putting all the apples in one pile, all the bananas in another. We're going to use that super simple idea to bring some serious order to this chaos. So here's our game plan. First, we'll define our algebraic shopping cart. Then we'll figure out what's in the cart, learn the one sorting rule you need to know, do the big cleanup, and finally, we'll talk about why tidiness matters so much. Ready? Let's start with what this whole thing is even called. All right, first things first. What do we even call this long, messy expression? Well, in the world of algebra, it has a name. And knowing that name is the first step to taming the beast. The whole thing is called a polynomial. And don't let the fancy name scare you. If you break it down, poly just means many. So a polynomial is just an expression with, you guessed it, many terms, all added or subtracted. Our messy shopping cart, that's the polynomial. And every single thing inside it, those are the terms. Okay, so if the whole cart is a polynomial, what about the individual items we've tossed inside? You know, before we can sort anything, we've got to know what we're actually looking at. Each one of those little chunks is called a monomial. Mono means one, so it's just one single term. Think of 11x squared, or 4x, or minus 5a. Each one is a monomial. And to make it even easier, let's just pretend the variable x is an apple. So when you see 5x, all that really means is I've got 5 apples. Simple, right? All right, now for the most important part. I mean it. This is the golden rule, the secret password that lets us clean everything up. It is the one and only instruction you need for this entire operation. And that rule is all about something called like terms. So what are they? Well, like terms are just monomials that are the same type of thing. For two terms to be alike, their variable parts, the letters and their exponents, have to be exactly the same. The only thing that can be different is the number out in front, which we call the coefficient. This chart makes it crystal clear. Look at the left side. 7x and 2x, those are like terms. That's just 7 apples and 2 apples. You can totally group those. But on the right, 7x and 4y? No way. That's 7 apples and 4 times bananas. You can't combine them. Now look at the bottom row, because this is really important. 3x squared and minus x squared are like terms. Let's imagine x squared is a box of apples. So we have 3 boxes and we're taking away 1 box. Simple. But 3x squared and 3x, they are not like terms. That's 3 boxes of apples versus 3 single apples. Totally different items. So if there's one thing you take away today, it's this. You can only add or subtract items that are exactly the same type. You combine apples with apples, boxes of apples with boxes of apples, and bananas with bananas. That's it. That's the whole secret. All right, the moment of truth. We know the rule, we know what the items are. It's time to roll up our sleeves, go back to that messy shopping cart, and finally put our new skills to the test. And here it is again, our chaotic polynomial, but it doesn't seem so scary anymore, does it? We're looking at it with new eyes now. We have a system, we know exactly what we need to do, and that system is just 3 easy steps. First, we're going to scan the expression and identify all the families of like terms. Second, we'll rearrange everything to group those families together. And third, we'll combine each family into one nice simple term. Let's do it. Okay, step 1, identify. Let's grab our virtual highlighters. First, let's find our boxes of apples, the x squared terms. I see 11x squared and, oh, there's a minus x squared. Got them. Now, for the single apples, the x terms. We've got a plus 4x and a minus 4x. Check. And finally, the bananas, our a terms. There's a plus 8a and a minus 5a. Perfect. Everything's been identified. Now for step 2, group them up. All we're doing here is rewriting the expression so that our families are sitting next to each other. It's like putting all the fruit in one part of your cart. So we'll put the x squareds together, the x's together, and the a's together. See how much better that already looks? And finally, the best part. Step 3, combine.
We just do the simple math for each little group. For our boxes of apples, we have 11 minus 1. That gives us 10x squared. For our single apples, we have 4 minus 4, which is 0. They completely cancel each other out. Poof, gone. And for our bananas, we have 8 minus 5, which leaves us with 3a. And just like that, our huge, messy expression simplifies down to just 10x squared plus 3a. How satisfying is that?
So, we did it. We took that absolute mess and turned it into something clean and clear. But why? Why is this skill so incredibly important in algebra?
Well, because tidiness is everything. First off, a simple expression is just way easier to read and understand. It's also the essential first step for solving bigger, more complicated equations. By cleaning up first, you seriously reduce your chances of making a simple mistake later. And maybe the most important reason, it reveals the true, simple heart of the problem you're trying to solve.
And you know, there's even an official name for this final, organized result. It's called standard form. This just means we arrange the terms by their power, putting the highest exponent first and going down from there. It's kind of like the universal, proper way to present your final, clean answer.
In the end, what we did here today was more than just math. It was about taking something complex and chaotic, applying one simple rule of organization, and finding a clear, simple answer inside. That's what algebra is really about. It's a tool for creating order. And if we can so easily tidy up this algebraic shopping cart, well, it makes you wonder, what other big, messy problems out there are just waiting for us to solve?